Hey, all right, in this video, we are going to solve some exponential equations using logarithms. So my goals, first and foremost, are to teach you what I call the sentence rule, and then we're going to do a bunch of examples of changing exponential equations into logarithm equations, and that way we can solve them. So here we go. So what I call the sentence rule is really just the definition of what a logarithm is really doing. So the way that I look at any exponential equation like this is that I read it in this way. I say x is the exponent on 3. And I'm going to write that down for you this first time. Most of the time I'll just say it out loud, but this time I'm going to write it down so you can really see how this works. X is the exponent on 3. That gives me 81. And there's a reason that I do this sentence. I want to read that a few times. X is the exponent on 3 that gives me 81, and really kind of understand how that works. And then when I rewrite this as a logarithm, I write it like this. X is equals, being the is, and then log has 3 letters. So I go the exponent on 3, that gives me 81. And now I have a logarithm. So these two equations, this exponential equation and this logarithm equation, mean exactly the same thing. I've transformed my exponential equation into the equivalent logarithm equation. And notice that this exponential equation would be rather difficult to solve. But once it's transformed into a logarithm, it can often be very simple to solve. This is one where we would use our change of base rule for logarithms, and we could just do log of 81 over log of 3. And now both of these are base 10, or we could have them be any base that we want. But doing those base 10, we can toss this into the calculator and we can get our answer. So this one, of course, is going to come out to the number 4 when you put that into the calculator. And you can see that that really is a good solution for this, that 3 to the 4th is 81 indeed. Now let's look at more examples of using this and extending the way that we use our sentence rule. So our first example is going to be a similar level to what we just did, but at the end of it, you're going to notice it doesn't come out to a simple integer as the answer. So we're not going to be able to sort of guess how this works. We're going to need to use a calculator, and I'm going to, on each one of these, just go to the nearest thousandth when I write down the answers. So let's use our sentence rule. We would write x is the exponent on 9 that gives me 8, or x is the exponent on 9 that gives me 8. So I've very quickly transformed this into a logarithm equation, and I can use the change of base rule to just do log of 8 divided by log of 9, and now those are both log base 10. When we put that into the calculator, it comes out to 0.946, and that's rounded to the nearest thousandth. Let's jump right into another example. In my second example for you, we have a base of e. So what happens when you do a base of e is it's going to work the same way. We start with x. X is the exponent on e, or x is the exponent on e. We have a base e. That gives me 3. Now, there's another way to write log base e. It's called the natural log, or sometimes I say the log natural, and it's called ln. So when you do ln of 3 on your calculator, you're going to get a value of 1.099, and we've found our solution, which you could, of course, check that in the original. You could do e to that power, e to the power of 1.099, and it would come out to 3. All right, let's look at another example. Now, on this one, there's going to be a little bit more algebra involved, but not much just yet. We're going to start out the same way as before by taking the exponent and saying 2x is the exponent on 5 that gives me 8. Now, we haven't solved for x, we've solved for 2x currently. So all we'll need to do is a little bit of algebra, divide both sides by 2, and we'll have x equals, now we figure out the log base 5 of 8 first, and then we divide that result by 2. So that's going to be log of 8 divided by log of 5. And then once we get that answer, divided by 2, and I get an answer of 0.646. Again, that's rounded to the nearest thousandth. In our next example, example 4, we have a slightly more complicated exponent, but we go about it the same way. We say 2x plus 2 is the exponent on e, remember that's natural log or log naturel, that gives me 7. So this is 2x plus 2 equals the ln of 7. Now I'm going to need to isolate the x over here by doing a couple algebra steps. So let's first subtract 2 from both sides. And make sure that when you do this, you don't do 7 minus 2. You're not going to break into that logarithm and reduce the 7. You're going to still have ln of 7, whatever amount that is, and then subtract 2 from the result. So here we have 2x equals ln of 7, and we would figure that out first. And then we would subtract 2 on both sides. And last, to solve for x, I'm going to divide by 2 on both sides. So I get as a final answer for this one, negative 0.027, rounded to the nearest thousandth. Let's move right ahead and look at our next example. So in this example, I see that I have 4x plus 3 is the exponent on 6 that gives me 71. And in a similar way to the previous examples, we're now going to do some algebra to solve. So I have my change of base rule, log of 71 divided by log of 6. Then I'm going to subtract 3 from both sides. And we'll finish off by dividing by 4. So I like to rewrite this to make sure I'm showing all of my work. But I'm going to do the calculation at the end. So we would want to figure out what this value is for the logarithms first, then subtract 3, and then divide the entire thing by 4. So I get as my final answer for this one, and you should always check on your calculator to see if you're plugging things in correctly, to see if I'm plugging things in correctly. If I'm making a mistake, I'd love to find out in the comments. So let's do one last example. So on this one, there is a slight difference here, and notice that I'm not actually going to start off by saying 4x is the exponent on, because I have this extra minus 2 involved over here on the right. So what I have to do first is add 2 to both sides of my equation, and I'll have 27 equals e to the 4x. Now that was very important to do first, because now I can read it as my sentence. If you try to read your equation with that sentence rule and it doesn't quite fit, it's very often you need to do an algebra step, or maybe 2 or even 3, before you read that as a sentence. It really needs to fit this exact format in order to do that sentence rule. So now we have 4x is the exponent on e that gives me 27. So this is ln of 27. And then I'll divide both sides by 4. And we can toss that in the calculator and get 0.824. So check to make sure that all those worked out well for you. And that's going to be some good practice on solving exponential equations using a logarithm.